Welcome everybody to the Green Adelaide webinar series for 2025. It's awesome to have you along this afternoon. My name's Christy Spire. I'm the team leader of the Nature Education team here at Green Adelaide, and it's a pleasure to host you in this series where we help to share the great work happening to make Adelaide cooler, greener, wilder and more climate resilient. This session is being recorded, as many of you will know, and will be available on the Green Adelaide YouTube channel so that you can access it afterwards and share it with your networks as well. We're coming to you today from Kaurna country, and so we always love to start by acknowledging this beautiful land and the people that have cared for it for many, many generations. Ngadlu Tampanthi, Ngadlu Kaurna, Yatanga Imparenti. It's good that we acknowledge that we're on Kaurna land, and we thank them for all the work that they're doing currently and that they've done in the past to care for country and to challenge us in the way that we care for country as well. So thank you to everyone that we work with and that we will get to work with in the future. Thank you for working with us. So today's session, the way that it will run, you're invited to ask questions at any time by putting them into the Q&A section, and we will answer as many of these as we can at the end of the session. So the session will be 40 minutes with Dr Jess Marsh, and then we'll have about 10 to 15 minutes at the end for your questions. So a lot of time for discussion. You're all on mute today, so we're giving the mic to Jess. So today's session is all about the wonderful world of invertebrates, nature's unsung heroes. And Dr. Jess Marsh is going to help us explore the fascinating lives of these heroes and highlight really why their survival is critical to our planet's future. Representing an incredible 98% of all animal species, invertebrates include bees, butterflies, spiders, crabs, snails, and countless others. Australia is home to an estimated 320,000 species, yet only 1/3 of these have been officially named, leaving so much still to discover. So we're pleased to introduce Dr. Jess Marsh, who's a renowned entomologist and arachnologist with a deep passion for invertebrate conservation and also fire ecology. She's a visiting associate at the University of Adelaide, conservation lead at Invertebrates Australia, which was just founded in 2021. Look forward to hearing about that, and also a counsellor for the Biodiversity Council. So we look forward to learning a lot from you today, Jess, and thanks for making the time to be with us all. I'll stop sharing my screen now and let you start sharing yours.
Excellent. Thanks, Christy, and thanks so much to everyone for coming along today. Just share my screen.
Fantastic. I can see that all clear.
Excellent. So yeah, thank you very much for everyone for coming along today. So I'm going to be speaking about Australia's invertebrates. I wanted to say quickly before I start that I'll be using a lot of pictures in this presentation. They're either ones that I have taken or I've attributed them to the photographer. So I thought I would start off this talk today just giving a brief introduction to me, in addition to what Christy said. So I'm a researcher at the University of Adelaide and a counsellor on the Biodiversity Council. And I'm basically all about the invertebrates. So my work spans from national scale studies across Australia to regional on-ground conservation projects and many, many things in between. So my main focus is taxonomy, or the naming and describing of species, and conservation biology. So the questions that really interest me are the challenges of working out what species we have, which are at risk, and how we can best protect them. So I work across various invertebrate groups, but spiders are my main area of interest, so expect to see lots of pictures of spiders. That's a slight content warning for those who are maybe a little bit scared. I also have a love for lesser explored areas such as caves. Caves usually contain really interesting species that are quite often found in one or very few caves and nowhere else in the world. I also, in my spare time, love hiking. And so the picture you can see behind me is one that I took when I did the northern section of the Hyson Trail. And I hope to complete the Hyson Trail at some point over the next few years when I have time. So I'm based on Kangaroo Island, where I live with my family, my 2 daughters and our pet dog. And I feel really lucky to be able to live regionally and work nationally. Kangaroo Island is an amazing place, and it's got some beautiful invertebrates, as you will see. So firstly then, what is an invertebrate? So the invertebrates are the insects, arachnids, worms, slugs, snails, squid, crabs, and many, many more. They come in a huge range of different shapes and sizes. So they can be tiny, from about 0.1 millimeters right up to the size of the giant squid, which is a massive 13 meters in length. Some have large wings and are powerful flyers. Some are long-legged and graceful. Some have no legs. And there are an awful lot of them. So as Christy mentioned, there's an estimated 320,000 invertebrate species in Australia, and they make up around 98% of faunal diversity. Or to put it another way, of all the animal species in Australia, over 90% are the invertebrates. And in South Australia, we're really lucky to have some really amazing and interesting invertebrate species. All of the pictures you can see here on this slide are species that you could come across in South Australia. They all occur here. And I really encourage you to get out and have a look, because we've got some beautiful, really interesting species just on our doorstep. So invertebrates are quite literally nearly everywhere. They occur from the bottom of the ocean to the top of mountains and many places in between. They live on land, in inland waters, and in the ocean. So some groups, such as dragonflies, such as this blue skimmer, which is also a South Australian species, it occurs elsewhere in Australia too, they spend part of their life as nymphs in the water, and so they're aquatic, and then they're terrestrial as adults, so they switch their habitat with their life stage. Some species of invertebrates are incredibly rare, with a tiny distribution, and exist only in a very small area. Perhaps the epitome of range restriction are species which are entirely confined to a single cave, whereas other species are really common and widespread, such as the cobweb spider or daddy longlegs. This species is one that you'd often see in your house. They like hang out in the top corners, and they're really interesting. So they are found in pretty much every country in the world, and they are very closely tied to humans. So in areas that are too cold for them to exist outside, they don't exist outside. They basically only exist in human buildings. I've included the image on the left, which is a spider that I found in a cave on Kangaroo Island, because this spider was only found in a single cave, and it's an example of a highly range restricted species, and just the contrast that you can get in the invertebrate world. So additionally, some species stay in one place for their entire life. They're homebodies, they don't move. So female trapdoor spiders, for example, the Kangaroo Island micro trapdoor spider, Magridia rainbow eye, which is a species that I've worked on for many years, they'll stay in their burrows for their whole lives, only coming out to catch prey. And this image that I've got here was one that I took whilst I was working on the species. And I love it because not only do the females stay in their burrows, but they also show maternal care of their young. So if you see on the corner here, there's a tiny little white spider, and this is one of her babies. You can tell it's very young because as they grow older, they harden and they go black and turn darker. So this is a really young little baby. The spider called will stay in the burrow with their mum for months. And so on the opposite side from these species that that stay in one place are those that can travel hundreds of kilometers. And the bogong moth is a great example of this. So these can travel hundreds of kilometers between estivation sites in the Alps, where they'll wait out the hot summer, to breeding grounds in the autumn. So what do invertebrates do? Well, to quote E.O. Wilson, invertebrates are the little, or sometimes really big, things that run the world, and they're crucial for ecosystem function. So invertebrates pollinate our plants. I think pollination is a well-known function that invertebrates perform, and it's crucial for plant growth and reproduction. They also disperse seeds. So, for example, some species of acacia, their seeds have little structures on them that are attractive to ants. And so what happens is the ants come along, take these seeds with these nice little fatty structures, and then take the seeds down into their ant nest. And that actually serves as a mechanism to disperse the plant seeds. Invertebrates also break down organic waste. So not only breaking down leaf litter and woody debris, but also we've got coprophages, which break down poo, and also scavengers that break down dead animals. So this breaking down of waste is important for many reasons. It cleans up dead things. It also, by breaking down leaves in leaf litter, it's been shown that certain organisms, primarily moths, actually play an important role in reducing fire risk by controlling that leaf litter. And they also, by doing all this, they cycle nutrients back into the soil so that plants can use them and take them up again. Invertebrates are also food for other animals, of course, and we know that some, say, for example, birds are insectivorous and they only eat insects. Studies have shown recently that insectivorous birds are actually declining at a faster rate than other groups of birds that eat other food, potentially an indicator that their invertebrate food source is also declining. So as well as all this, invertebrates keep the ecosystem in balance. And by this, I mean like the ecosystem, the invertebrate ecosystem is a complex web. And you need as well as needing the pollinators, the scavengers, the coprophages, you also need the predators and the parasitoids and the parasites that work in this web to keep all the organisms in balance. And so a spider's role in this ecosystem to balance out those species is a really important one to keep the web going. If we look at aquatic invertebrates, then in freshwater, invertebrates play a really important role for cleaning our water, for filtering. So mollusks and bivalves, like fresh water mussels, are really important for filtering water. On the other hand, in the ocean, invertebrates build coral reefs. And coral reefs are really important along our whole coastline for flood defense. So putting this all together, you can see that invertebrates do a lot, and that they're also really important for a whole range of different levels of functions. So here in South Australia, we have some really amazing and scientifically important endemic invertebrates, species that are found in South Australia and nowhere else in the world. We should all be really proud of these species, but I know that a lot of people aren't necessarily aware of them. So I wanted to give a quick introduction to some of Australia's iconic endemic invertebrates from different regions. Now, there's a caveat with this. This is just a taster, and it is an unashamedly biased list, so expect to see lots of spiders. There are many, many more awesome invertebrates out there than this in South Australia, but here are some of my favourites. So starting off with a species that I have worked on for quite a few years now, the Kangaroo Island assassin spider. And these are awesome invertebrates. They're very unique and interesting. So they're an ancient lineage. The oldest known member of the assassin spider family was actually found as a fossil in Mongolia, and that was dated back to be 163 million years ago. This species here, the Kangaroo Island assassin spider, is slightly more recent than that. It was known, it's believed to have diverged from its closest relatives, so split away from its closest relatives, between 23 to 5.3 million years ago. So it's still pretty old. It also has bizarre looks, as do all of the assassin spiders. So if you can see on this, the photo we've got here, it's got a very elongated head region and really long mouth parts, I'll show three. Its other name, the other name for this group are pelican spiders, and I think you can probably see why. They're very unique looking spiders. They're also specialist hunters of other spiders, and I was lucky enough with this female that I photographed back in 2022 to actually manage to get a photo of her catching her prey. They're very efficient predators. They stalk their prey very slowly and come up behind them and then grab them. And to be honest, the couple of hours I spent observing this animal going about her way and catching a prey were some of the best hours. No, it was really, really interesting. So the Kangaroo Island assassin spider is only found in a very, very small area in northwest Kangaroo Island. It lives in elevated leaf litter. So if you can see in this picture here, the leaf litter that's suspended in these sedge-like vegetation, that's where we find it. And unfortunately, that habitat is highly flammable. So this species was heavily impacted by the 2019-2020 fires. At the time of the fires, it was only known from one location. I got out there as soon as I was able to get into the fire ground to survey for the species, and this is what I found. So as you can see, not only has the vegetation and the leaf litter gone, but so is much of the organic material. So after the fires, I spent a long time trying to find surviving populations, and eventually we did find some. We found some about 4 kilometres from this original site, and they now are only known to occur in one quite large but one contiguous patch of very long and burnt old vegetation. And because of this, they are critically endangered under the EPBC Act and the IUCN Red List. And there's unfortunately many threats that are impacting that surviving population. But with Invertebrates Australia and other organisations, I'm working to try and understand those threats and to protect the species. So the next species I just wanted to briefly touch on was the dinosaur ant. Now, this is another rare and unusual and very primitive invertebrate. So this species is now only known from the Eyre Peninsula, and it is very rare. So there have been quite a few surveys conducted for this species by experts, but few have ever been found. Now, as the name suggests, they're very primitive. And in fact, it's considered a living fossil. It's little changed for millions of years. And so what you're looking at now is like looking back in time. They are, like the Kangaroo Island assassin spider, unfortunately also critically endangered. The main threats to this species is fire, climate change, habitat loss. Now on to one of my favourite species. This is the nullarbor blind cave spider, Troglodipleura Beirut pacbari. So this species is a very large, it's about the size of my hand, maybe a bit bigger with legs outstretched, cave adapted spider. So it's completely eyeless and it has very long limbs. If you can see on the photo we've got here, right at the end of its limbs, it's got these kind of shiny silvery patches. Well, these are actually sensory patches of sensory hairs, would allow it to move around its pitch black environment and sense any movement or vibrations. Watching these species move is amazing. They're very robotic, almost very slow and using their senses. So these animals are only found on the nullarbor. The whole genus is restricted to the nullarbor. This particular species is in South Australia, and they are globally significant. So they belong to a group called megalomorph spiders, which are the primitive spiders, and also includes funnel web spiders, tarantulas, trapdoor spiders, mouse spiders. And this group of spiders, the nullarbor blind cave spiders, are the only cave adapted megalomorph or primitive spiders known from Australia. And they are amongst the most cave adapted megalomorph spider in the whole world. So they're very important and very significant in what they can teach us about those adaptations and about evolution. They're also very rare and enigmatic. So I went on some surveys for this species in 2021, and prior to that stage, the group was only known from fragments of dead spider or a few little juvenile babies. So we went out with some cavers, and a caver myself, and we went to try and find them. And we were the first people on record to observe these spiders alive and in their natural habitat. And it was amazing. So we came across this female, and yeah, just seeing her moving around and knowing that so few people have ever seen them before, it's a really privileged thing to do. Again, with the other species, there are threats that are impacting this, which were quite hard to take. So foxes, for example, a lot of the caves that looked suitable habitat had foxes throughout, fox scats and dens into all accessible chambers. Climate change and disturbance by people is also a threat. Now to the Mount Lofty Ranges, and so for anyone who lives up in that area, then here's one for you. This is another very intriguing and very unusual little invertebrate. So it's Archaeopelluria eureka, and it's the Mount Lofty mite harvestman. So this species is restricted to very few sites in Cleland Conservation Park, only to a very, very small area. It's ancient, and its being there is very unexpected. So there are two other genera of mite harvestman in Australia. And this species isn't related to those. Its closest relative is actually in South America. And so this species, genetic analyses show that it split from its closest relatives around 45 million years ago. Now, it's a really interesting species. Again, it has threats. Phytophthora, blackberry infestation, fire, climate change are likely impacting this species. Now to the last species in our trip around South Australia. This is the Flinders Ranges scorpion, and it's a really impressive beast. It's one of Australia's largest scorpions, around 12 centimetres in length, and it's only found in the Flinders Ranges. Now, one of the reasons I wanted to include this is because it's an example of another type of threat that's potentially impacting Australian invertebrates, and that's the pet trade. So a study by a colleague of mine, Charlie Lassaline, in 2023 showed that this was actually one of the invertebrate species in Australia that's most highly traded in the pet trade. We don't know much about the threats of that on this species, but because it's got a very restricted range, it's likely that it does have some impact. And we're at the moment going through conservation assessments to see if we can get this species nominated as threatened. So invertebrate conservation then, a field that I work in and a field with many challenges. So as Christy mentioned at the start, there's an estimated 320,000 invertebrate species in Australia. Only a third of these are described though. So for 2/3 of the species, we really know nothing. And even with that third of species that are described, most of them are understudied, most of them are unknown. So there are very few occurrence points. We don't know where they are. And there's very little monitoring of populations to see which populations are at risk of extinction and which are doing okay. So a study that I did after the 2019-2020 fires, where we tried to estimate the impact of fires on Australian invertebrates. During that study, we gathered together all records of invertebrates in Australia, and we found that over half of the described species had no occurrence points at all. The other thing that is a challenge is that invertebrates are mostly underappreciated and largely overlooked for conservation concern, investment, and resourcing in favour of the vertebrates. So I wanted to just quickly talk about these pictures of the species that I put here and a bit why I've got them. So in these 4 pictures, there are actually 5 new species of invertebrate and likely new genera. Now, I found all these species on one caving trip on Kangaroo Island, and they were all found in 2 caves. Prior to me going into those caves, only one of the species was known before, and again that was known from records of dead, broken beetles. So it was the weevil on the left. So it was really an illustration of how much is not known, how much there is to find, and also the risk of extinction for these species that aren't known, that are confined to really small areas, is actually quite high. The risk of them going extinct before someone finds them, before someone documents them, is high. So how are Australia's invertebrates doing? The honest answer is we really don't know. So with some colleagues of mine, we set out to try and estimate the number of extinctions of Australia's invertebrates, both past and ongoing. So here is the paper in which we published our results. It is open access, so feel free to have a look, and also I can send you the link if you're interested. So how did we do this? Well, basically, we had two things that we wanted to calculate. Firstly, we wanted to estimate the total number of extinctions, and then we wanted to estimate the ongoing loss. So to estimate the total number of extinctions, we used two methods. Firstly, we took the proportional extinction rates of Australian vertebrates and plants, which is better known, and extrapolated that to the number of Australian invertebrates that we have. Secondly, we also extrapolated the proportion of extinctions recognised among all of the world's invertebrates to the number of Australian ones. So we basically took two measures. One, the known extinction rate of vertebrates and plants of Australian species, and then the worldwide extinction rate of invertebrates. To calculate the ongoing loss, we used two methods again. So we took the rate of extinction since 1788, so the number of extinctions per year. We then treated that separately, as in one, that extinction rate is stable, and secondly, we treated it as if the extinction rate would increase with the number of humans in the world, so with human population size. All of these figures gave us upper bounds, lower bounds, and middle ground of certainty, of best guess of what we think is going on. So currently, 10 species of invertebrate are officially recognised as extinct in Australia, and only one species is recorded as extinct under the EPBC Act. That's one invertebrate species. However, our study found that actually, as a best guess estimate, and this wasn't the highest, anywhere near the highest bound, that actually over 9,000 invertebrate species have likely been lost from Australia since 1788. Importantly and dishearteningly, we also found that 1 to 3 species are being lost every single week and will continue to be lost moving forward. So I've included this chart from our paper to illustrate two main points. Firstly, the stark contrast between the numbers of vertebrate extinctions compared to invertebrates. So the vertebrates here on the right, and you see it's a small pie. The invertebrates is a much bigger pie on the left. Now, this is to be expected given the vastly greater number of invertebrate species, around 320,000, compared to vertebrate species, which is around 8,000 in Australia. But it is in stark contrast to the conservation investment and resourcing that is allocated to these different groups. The second thing I wanted to highlight was the composition of the invertebrate extinctions. So as you can see here, that around 3,000 extinctions were called the so-called dark extinctions, where a described species goes extinct unrecorded. In the paper, we coined the term ghost extinctions as a name for the 6,000 odd species that went extinct undescribed, undocumented, and unrecorded, so effectively vanished without a trace. If we go back to the cave species that I mentioned earlier, you can see how easy it is for these ghost extinctions to happen. There are so many species out there and so small a workforce. So what are the implications of these findings? Well, along with climate change, biodiversity loss is recognised as a leading threat to our natural and agricultural systems and to our ways of life. Our findings of an exceptionally high level of unrecognised, undocumented and unstemmed loss of a functionally important and large component of Australia's biodiversity are a wake-up call. There needs to be a shift in the way we currently approach conservation to better include invertebrates, to better prevent extinctions. In 2022, Australia joined 196 countries to pledge a commitment to zero new extinctions under the Global Biodiversity Framework. Now, this goal is incredibly ambitious, but it should be applauded. We want to reduce, we want to halt extinctions. However, unless we address this decline, that pledge of zero extinctions is destined to failure. So, okay, we're estimating that there's a lot of extinctions going on, most of which are unrecorded. So what are the main threats to invertebrates? Well, the threats are many, interacting, and incredibly complex to manage. So fragmentation, habitat loss, degradation of habitat, overuse of pesticides, climate change, and widespread apathy. So despite the critical roles invertebrates play, they are so often overlooked, misunderstood, placed in the too hard category. And this applies across all levels of society, from the opinion of the general public, like it's a spider, let's squash it, right up to high-level decision-making and policy. And this is reflected here in South Australia, that in the fact that only 3 species of South Australian invertebrate are currently listed under Australia's EPBC Act. 2 of those species were ones that I nominated in my spare time as a volunteer after the fires because I was concerned about them. And no species of invertebrate are listed under SA state legislation. So which species are likely at most risk? So many invertebrate species we know are at an elevated risk of extinction, and we can look at their traits and the habitat they live in to try and predict which ones are likely at most risk. And we think that those with highly restricted ranges, those that are habitat specialists, those that have a very low dispersal ability, or those that are obligate associations with a host plant or animal are at particular risk. So the Kangaroo Island short-legged harvestman, Nunciella kangaroensis, that's restricted to the northwest section of Kangaroo Island, similarly to the Kangaroo Island assassin spider, it's in the same place. And a lot of species of pinwheel snails in the family Chiropodidae have those traits. They're highly restricted, they're specialist to habitats, they need humidity, they need water, and they have a low dispersal ability. The other species that we've got here have a really interesting life history and are an example, and the Mallee bronze azure is an example of a species that is at risk because of its association with its host animal. So I'll just run through its life history just very quickly because it's interesting. The Mallee bronze azure so the butterfly will lay its eggs near the entrance to an ant's nest. When the eggs hatch, the caterpillars emit a pheromone which may mimic the smell of a queen ant. This then tricks the ants, making them pick up the caterpillar and take it down into their nest. The caterpillar then lives in the ant nest, predating on the young ants until it is ready to pupate and eventually emerges as a butterfly to start the cycle again. Now, this species of butterfly, the ants it depends on, is one species of ants, Camponotus terebrans. And you can see how not only do you have the threats that are impacting that butterfly that make it at risk, but also anything that potentially impacts those ants kind of compounds that risk. And that's why we can see, or we have seen, cascades of extinction where you get a species that goes and then any other species that are dependent on it also go. So invertebrates in conservation on a national scale, only 0.09% of Australia's described invertebrate species are currently listed under the EPBC Act. And this is not a reflection of empowerment. It's likely that the numbers actually at risk are vastly higher than this. And this really is reflective of widespread apathy, pervasive taxonomic biases in community concern and conservation investment. However, it's certainly not all doom and gloom, and things are really improving. So the work of Invertebrates Australia, which I co-founded in 2021 and which I'm conservation lead, the work of the Biodiversity Council, which I'm a councillor on, and other organisations are driving forward greater recognition of the importance of invertebrates. Combined with this, there have been some really successful citizen science initiatives like the Christmas beetle count, which is run by Invertebrates Australia, that are really serving to get people interested in invertebrates and get people involved. So, what happens if an invertebrate species goes extinct? Now, I get this question asked of me a lot, especially by the media. So let's take one of the species that I work on as an example, the Kangaroo Island assassin spider, which unfortunately is at very high risk of extinction. So what happens if the Kangaroo Island assassin spider goes extinct? The answer, honestly, who knows? Maybe nothing, maybe it's gone. There's a few sad scientists around, but the world carries on as normal. However, invertebrates such as the Kangaroo Island assassin spider tend to occur in what's called hotspots of endemism, such as Northwest Kangaroo Island. And this is where multiple species that are very highly range restricted and dependent on certain habitat types co-occur in one area. And now threats that impact those areas, such as fire, don't just impact the Kangaroo Island assassin spider, it will impact that whole range of species. And so the likelihood is that much wider invertebrate species loss is occurring. The only reason we know the assassin spider is imperiled, the reason it is listed in the first place, is because myself and a colleague in Queensland who worked on the species before the fires realised that the impact of the fires may have been catastrophic. Really, this species just happened to be lucky that I live on KI and that I cared. It could very easily have gone under the radar. But the thing is, there are so many other species of invertebrate out there that are likely equally imperiled, if not worse. Species which do not have the custodians willing to spend their time caring about them, nominating them for conservation listing, conserving them. And as our paper shows, ghost extinctions, where an extinction happens unrecognised, make up the vast majority of invertebrate species loss in Australia. And the consequences of all that, who knows? It's very difficult to predict. So one thing we can do is to try and think about about the potential ramifications of species loss, is to look at other better known examples. And this study that came out in 2024, I think, provides a really interesting example of what can happen when you lose a species of invertebrate. Now, the story is set in South Africa, and we start off with a species of acacia tree and a species of native ant. So the native ant and the acacia have a mutualism where the ant lives in the structures in the acacia tree, and in return it repels elephants, which are the main herbivores, by stinging them. So the tree doesn't get so eaten, the ants have a place to live. However, in came a species of tramp ant, one that is also found in Australia, and that basically knocked out the native ants. The native ants went from that area. The tramp ant moved onto the acacia tree. Now, the tramp ant didn't have as an effective method of repelling elephants. So basically, elephants came in, ate the acacias. What happened then was that the habitat opened up. There's less vegetation, less canopy cover. What this meant is that zebras, which were the lion's preferred prey, were less easy to hunt in that area because the lions relied on cover to come out and stalk and catch their zebra. So the lions had to switch their prey to buffalo, which were easier to catch out in the open. And this example, I think, just kind of gives you an idea of the complexities involved and the potential implications of some of these losses. it's very difficult to predict, and the kind of wide-ranging impacts can be quite far removed from the actual species itself and the species that depend on it. So what needs to be done then? What can we do? Well, firstly, as a country, there is a lot to be done. Firstly, we need to work out where the areas of importance are, and we need to protect them. We need to control threats, we need to protect habitat, and we need to reduce large-scale pesticide use. We also need to address the gaps. So taxonomy, or naming and describing of species, is so important to try and bring up the proportion of species that we have described that we can account for and we can track. We also need more information on conservation, so on what are the threats that are impacting species and how we can protect them. We also need information about where the species are. We need more surveys, we need more monitoring. We also need to get more invertebrate species listed, and this is the job of scientists of Invertebrates Australia. It's one of our priorities, is to get more species listed so that they are accounted and are involved in conversations about conservation. We also need to raise awareness. So citizen science helps to provide data that can be really useful. Like, there's some great findings coming from citizen science. But I think as importantly as that, it encourages people to get involved with invertebrates, which then raises the invertebrates profile and helps counter and address this apathy to create an environment where invertebrates can be more meaningfully included in conservation, and in a way that politicians, that decision makers, that policy makers actually sit up and take notice. So from an individual perspective then, what can you do to help? Well, there's a lot that we can all do. Firstly, we can make conscious decisions by planting local plants, by keeping debris and logs and leaves in your garden. This creates really important habitat for invertebrates. Equally, reducing pesticide in your garden, or encouraging pesticide reduction in green spaces if you don't have a garden, are really good ways to make sure that those places are safe for invertebrates. If you think about it, gardens and green spaces may individually only be very small areas of land, but if we take them in combination, they make up a huge area of habitat, and that can be really important habitat for some of these invertebrates. The other thing I think is really good to do is take part in citizen science initiatives. That data, having eyes on the ground, people looking for things, is really important. So I wanted to finish up today by just a closing few sentences. So I think collectively and individually, we need to care, to notice, to respect and to value these little creatures and the roles they perform. I think we need to understand why we need them, to know what we have got and also what we might lose. I've seen a shift in thinking in the years I've been working in invertebrate conservation. Things are changing, they're getting better. Invertebrates are being brought into the conversation, and that's brilliant. We just need to keep up that momentum. In this day and world, with the changing climate and all the pressures on it, we need these little ecosystem engineers. We need these invertebrates to continue doing their thing, probably more so now than ever. And the benefits they provide us extend beyond ecosystem services. Invertebrates are so accessible, you don't need to go far or spend much money or any money really, to experience the wild drama and beauty of their world. It really is just out on our doorstep. And there is so much to see, so much to learn. But if nothing else, observing these animals, how they interact and what they do, is great escapism from the events that are playing out across the world, the stresses of these times. I think we need these little creatures. We need to protect them, to respect them, and to value them. And honestly, it's not too late. We can make a difference and we can protect them so that they're here for future generations to enjoy. Okay, so thank you so much for listening, everyone. I've put some questions, some resources here, if you're interested. So Invertebrates Australia if you go to the website, has a great section on resources on invertebrates. I've just put a couple of South Australian specific ones. I love the South Australian Museum, and the South Australian Biodiversity Gallery is a great way to go and have a look at the invertebrates that are in South Australia. So I encourage you to go and open some drawers, have a look. There are many South Australian sites that are great for learning about invertebrates and for going and checking identifications. One of them is the SA Butterflies and Moths group. But yeah, if you're interested, I encourage you to go and have a look. Excellent. Thank you.
Awesome. Thank you so much, Jess. Thank you so much for covering, the big picture as well as the ways that people can get involved, which is great. And we do have some questions here that I think you started to answer actually at the end there. If you want to stop sharing your screen, because something else has popped up there. I think they're just your notes. Brilliant. And maybe this question will help us get down into a few of the initiatives maybe that Invertebrates Australia is looking at. What is your view of the best ways to direct and encourage citizen science efforts for invertebrate conservation? So I know that, you really highlighted that at the end there after that person asked that question. But just if there's any particular initiatives or ways to encourage citizen science that you've seen work well.
Yeah, absolutely. So that's a good question. So one of the absolute massive benefit for citizen science and invertebrates is iNaturalist. So I don't know if anyone's, I'm sure many people are actually familiar with it, but it's a great place where you can not only upload your pictures and your occurrence data for invertebrates or other groups, but you can also, there you can help with identifications. So iNaturalist is a go-to. But there are great initiatives. As I mentioned, the Christmas beetle count run by Invertebrates Australia, it's been so successful. So the way that we've run it, or the people who are running the programme have run it, is that people send in photos of Christmas beetles that are verified by experts, and then we collect all those records. There's been thousands of records sent in, and what it's meant is that we've found species that haven't been seen for tens of years. We've found species that are like one that hadn't been seen since the 70s. And so that sort of information is really good. I think pick a group of invertebrates that you like, or go for many, take photos, play around with iNaturalist and speak to people. I think one of the beauties of the invertebrate entomologists or ethnologists is we are a relatively small group, but we're also really love people interacting with invertebrates and loving invertebrates the way we do, and so there's nice communities there. So yeah, I think just give it a go and enjoy.
Yeah, fantastic. A bit of a broader question before I go into a question here that's a little bit more detailed, but and I know you kind of got there, but just interested what has led to the focus more on vertebrates and over invertebrates? Is that just been a funding thing over time, or has anyone kind of really analysed that, or is that just where we've landed as a species?
I think there's a lot of reasons that vertebrates have been prioritised. Firstly, a lot of people think they're cuter. Cute and fluffy. People look at a spider and think, that needs not to be there. But as well as that is that fact that invertebrates are difficult. They're hard. There's a lot of them. We don't know much about any of them. So the challenges we're facing are not easy to be dealt with. There's so many challenges purely because we've got 320,000 species.
That's right. Just because of the high numbers alone increases the complexity.
Absolutely. And I think it's that whole combination, but it has resulted in, it's the species we know less about, we know even less about, sort of thing. We're prioritizing those we know more about, and it's resulted in this state where we don't know really what's happening with a lot of species.
Awesome. And in terms of, you definitely showcased all the different ways I think that communities and individuals can get involved, but I think through listening to the session today, there was that real focus on advocacy as well, and helping leaders to understand the focus on this as well. Is there ways that groups and individuals can do that? Is that through yourselves at Invertebrates Australia to kind of gather people together to say that this is an important area?
Yeah, absolutely. So being a voice, using your vote is very important. But joining up, come and have a look at the Invertebrates Australia website. And, we have members. I think it's getting together enough like-minded people and showing people just, there's a lot of really cool stuff there. They're not all creepy crawlies. And so I think really building that momentum and actually just caring and noticing is, for me, that's a really important step to get past the yuck factor, which, not everyone feels. I know that, but I think it is an overwhelming reaction for some people that does create barriers.
Yeah, so that how do we tell the story and really highlight the uniqueness of these creatures and that kind of awareness raising. Awesome.
I think, I was going to say, with the invertebrates, the ones that I work on, the more you learn about them, the more you observe them and watch what they do, the more you realise how complex their lives are, how interesting, with maternal care for the young, the different interactions they have. And it really is that case of the more you learn, the more you can then appreciate them and the more you realise there is to learn. But it's getting to know them and getting familiar is that first step, I think.
Yeah, awesome. Yeah, and I loved that challenge that you put to us all, that we need them in our context at the moment, and forcing ourselves to slow down and be involved in that micro world is good for a whole range of reasons, which is fantastic. Such a good challenge. Now, there's a few questions here just around leaf litter and fire and that type of thing, and how to, ecosystem support for these amazing little heroes. What's the balance between keeping leaf litter under trees or amongst vegetation, or reducing leaf litter because it can be a fire source? Again, this just raises the complexity of
it is incredibly
complex.
It's incredibly complex, and it's context specific, because an answer for one place may not be the same answer for another place. I think my view is try and have a balance if you can. Leaf litter is really important habitat. We know that a lot of species occur in leaf litter and don't occur anywhere else. So much so that species of invertebrate under a particular tree, you'll have different groups of species under different species of tree. And so you have different eucalypts and you'll have different communities living under there. There's a lot of specificity in it. Yeah. So I think it's difficult, but balance and context, I think.
Yeah, definitely. And I think this question, I think you've kind of already answered, but I'll put it out there because I think, again, it illustrates that context-specific work that everybody is desiring to think through. So this is from a local council that's trying to revegetate reserves that are just trees with kikuyu turf. And they were recently told that using mulch isn't good for invertebrates. However, we use mulch to keep the weed load down and reduce herbicide use. Is the use of mulch preventing increasing invertebrate species numbers? Again, another example of the complexity.
Yeah, and I would say mulch is for a lot of species is beneficial. So it depends. It's context dependent, but
Mulch over herbicides and grass. Would be useful. Yeah,
absolutely. Creating, if you think. What we often think of with invertebrate habitats is that complexity of layers and structures, and the horizontal complexity as well as vertical complexity, which you get with leaf litter and which, say, with grasses, you don't get so much with non-native grasses. And so it's trying to think about that in terms of habitat, is increasing that complexity.
Yeah, fantastic. Awesome. And one more around awareness and how we talk about these things. This person struggles to speak to students and teachers about why biodiversity matters and why each species matter. Any tips for how we can inspire people to understand the importance of them all and kind of tell that story in a way that resonates and inspires from the work that you've done?
Yeah, I mean, that's a challenge that I face all the time, is trying to get past
Yes.
this that kind of barrier of like, why does it matter? And I think just trying to use examples of, like with the ants and the lions, of the complexity, that, you know, this is complex and it's such a fine network of group species all interacting together, that really that biodiversity as a whole, not just individual species, but those interactions are as important. And so maintaining that biodiversity to keep things functioning, to keep everything ticking over is yeah, that's kind of the key. But it's not something that's easily explained in simple terms. But yeah.
Yeah, but I think you're right though. Yeah, stories and examples that, yeah, those tangible examples that people can hear. Yeah, whether, yes, and sometimes some international examples can be great, and those local examples, and yeah, just some of those yeah, stories that you've told today about the uniqueness of these ecosystems is what draws me in when you're listening to someone. It's the stories, and yeah, not necessarily like all the data as such as well. So yeah, that's fantastic. Great question. How possible is it to ban pesticides from supermarkets and those kind of stores and that kind of thing? I mean, I suppose that comes back to that kind of advocacy role that individuals have around advocating for different different herbicides and things that are, you know, they're in the system. How do we reduce them or make calls to help get them reduced?
Yeah, and it's a very difficult one. And of course, it's going to take a shift in mindset, and we need that shift in mindset to be adopted more broadly in order to get it more acceptable to ban things like that on a home level. I think people making those conscious decisions themselves, and yeah, making it generally acceptable to say no to pesticides, to kind of celebrate the fact that I'm a spray-free garden, for example, helps shift the way in thinking to that it's not necessarily a good thing to spray everything.
That's right. Yeah, and it is those kind of broader scale companies and places where that's happening at a level where you can advocate and influence down to your home garden as well, in terms of visibly demonstrating what you're doing and how you can showcase that at that really small scale, and then influencing the wider scale, like you said before as well, through your vote or through coming together with groups of people to show what's important. Yeah, it's a lot. There's a lot to do, but thank you for framing it in a way where there is some clear actions and ways that people can jump into this area further as well, because I think that's sometimes in this area everything can feel a bit overwhelming, but there are things that each of us can do. So thanks for that. Reminder. I'm just flicking through the questions, but I think there's some thank yous and so forth coming through in the chat as well, which is excellent. But I think we've covered off on the main key questions. Is there anything else that you wanted to add quickly before we finish off, Jess?
No, only that, you know, it's like things are changing, things are improving, we're getting momentum, and I think this is Invertebrates Australia's, when we first started it, it was like, yeah, let's start a national charity, why not? And now it's gaining momentum, and we're making difference, and it's something that feels really positive. And I think we need to keep hold of that positivity, because it's easy to get swamped by, you know, the problems in the world, especially now. It's the state of the world at the moment, but yeah, there's a lot that's happening, and it's improving with the invertebrates, I feel.
Yeah, fantastic. Yeah, especially for those of you that have worked in this area for many years as well. It's really important to come together and to know that all that work is counting towards something, and that we can all come together and request for more monitoring, more surveys, more people out there. There was a graduate that just said thank you, who's keen to learn and get into the area more as well. So we need that investment in people on the ground doing this monitoring and survey, as well as the volunteers and the citizen science as well. So that's another way we can join in. So but thank you so much for your time today, Jess, and everyone that's online will be sure to send through all those different links and awesome information and slides that Jess presented today, so that everyone can keep sharing the word with your networks. And our next webinar in this series that's coming up in March will be around urban soil biodiversity, which will be great. The hidden key to healthy communities and thriving ecosystems, with Dr. Jake Robinson. And so, as you can see, everything connects. So we're going down deeper into the soil. We'll send more information on this session out to you if you've registered with us today, and there will be a link of the talk that you can share with your networks as well. So we hope you can join us for future sessions, or watch some of the ones that are already online on our YouTube as well. So thank you so much for joining today, and take care.
Thanks.